Okay, so as I told you, registers are something which can hold the value of 0 or 1 for the given time. So if the clock cycle says memory state, if the operational state of your flip flop, whether it is D flip flop or any other flip flop, if it is kept in memory state, it has capability of storing that one bit. So one flip-flop has capability of storing only one bit. If I want to store a 4-bit number, for that I will have to use a 4 flip-flop, right? So how many bits you want to store? That many flip-flop is required. Okay. So register is nothing but a 1-bit memory cell. Now when we are storing something, then it is also called as that we are registering it. We say, you go register your name. Register your name means you store it somewhere, you keep the record of it. Registering means keeping a record of something. So that is why this word register came into picture. So register is simply a collection of flip flop which is taken as one entity. Okay. And it can hold information with respect to digital system. So it can be zeros and ones, and binary system is completely of zeros and one only. So with the combination of these things, it becomes the state of the register, or we can call it as content of the register. Okay. So now when you are storing certain information, you are also required to transfer it. You are also required to transfer it. Transfer it means what? You are required to uh, transfer your data out of your memory in certain ways. Okay. So I will write here registers. That is your topic now, registers, or we can use it for shift registers. Okay, I will write all the 4 possibilities here. So under this we talk about shift registers, and under shift register the 4 possibilities with which the register will transfer the data stored in it. So number 1 possibility is serial in, serial out. Okay. First possibility and most easy one is serial in, serial out. Second possibility is serial in, parallel out. All these are very easy actually. Serial in, parallel out. Third possibility is your parallel in, serial out. Okay. Parallel in, serial out, that is also very simple. And fourth one is parallel in, parallel out. So these are the 4 ways in which the data can be transferred, in the way that data can be transferred from the stored registers. So that is why we call it a shift register, because the data whatever is stored in should move out also. So that is why how the data shifts comes under shift register. Now we do not want to use 4 different circuit for this possibility. So there is one more under shift register. You will have to study 2 more circuit which comes in a more complicated form. So the first circuit what you have to study is parallel in unidirectional shift register. Okay. And let me not give more importance to this parallel, because parallel anyway comes into the register picture. So I will write it is a unidirectional. I told you that there is an importance of how the data is moving. So first one I will teach after these 4 register is unidirectional shift register. Unidirectional shift register. And the second one will be, because I told it is important that how the data is moving. So one is unidirectional shift register, other one is universal shift register. Okay. Universal shift register. Universal shift register is the circuit in which we uses muxes, D flip flop, all that. So the first time you will see a circuit which will have combinational component, as well as sequential component also. Unidirectional shift register will have your sequential component as well as a few combinational gates will be there. So under this register topic, you need to study this 4 types of shift register, then unidirectional shift register, and the last one is universal shift register. Universal shift register is something which can do bidirectional. So it is even more advanced than this unidirectional. Okay, so let us now go on to shift register, the first easiest one, serial in, serial out. Okay, so this is the circuit of your serial in, serial out. What you can see here, this is a 4-bit serial in, serial out unidirectional shift register. In this, what happens, you all are very clear about the working of D flip flop. So what you can see, Q bar is not connected and you have only one input of D. So what happens, whatever data is brought here, whatever data is brought here and this serial data in, what happens, after the one clock cycle, Q becomes equal to D. After next clock cycle, the data which is connected to this second flip-flop input Q of the previous flip-flop, that data is available here. So then what will happen, after the next clock cycle, second flip-flop output will be equal to that data. Then the same way third, and then the same way fourth. So what will happen, the data will move from serial data in to this clock cycle 1, then clock cycle 2 second, clock cycle 3 third. So this is, and when you are pushing this Q here, this serial data in can push in your next bit of data. Same way, last will push like this. So what happens, if I am putting the data here as 1 0 1 1, so after this is my first input data, suppose. Okay, so if this is my first input data, clock cycle 1 2 3 4, after fourth clock cycle, this one will appear here, right? Next, by the time this one would have pushed right, 0 would have been given. So after the fourth clock cycle of that, you will get 0 here. Same way, this one will come here, last one will again come here. So you can see it is very simple, but it will not give you data fast because it is serial in, serial out, right? Because it is serial in, serial out, the data you will not get it immediately. So the complete 4-bit data will be available here as 1011 after how many clock cycle? Can anybody tell me?
3, ma'am.
See, when the data is here, clock cycle 1, it came here. Clock cycle 2, it came
4,
here.
ma'am. 4.
Yeah, right. So for the first one, it will be 4 clock cycle. For this one, 5th clock cycle. This one, 6th clock cycle. This one, 7th clock cycle. So the complete data was available to you after 7 clock cycle. Complete 1011. It became available to you after 7 clock cycle. Right. So this is about serial in, serial out. Serial in, serial out. Now, if I want to use the same thing, serial in, parallel out, the circuit is same, only difference is, you can see here, connection was not given to this intermediate bits. You had your connection only here, serial data out, output is only this. So this became only one place data is getting in and only one place data is getting out. So you have the option of only one bit for inputting the data, one bit for outputting the data. So that is why it is serial data in, serial data out. For serial in, parallel out, what do they do is, they will give connections at each flip-flop. So what will happen? The data will be fed serially, but you need not wait for 5th, 6th and 7th clock cycle. In 4th clock cycle only, the data can be out parallelly. This is what it is showing. Serial in, parallel out. So the same 1011 data, if I try to push in here, so first 1 will go, then 0 will go, then again 1, then again 1. So what will happen after the fourth clock cycle? This first one will be available here, and at this portion 0 will be available, and this portion 1, and this portion 1. So after 4 clock cycle, the data of this 1011 which is entering serially in here will be available like this, and at the fourth clock cycle itself, my QA, QB, QC, QD, all the 4 data will be available to me. So this is called as serial in, parallel out, using 4D flip-flops. And you can see all are governed by the same clock cycle. All are governed by the same clock cycle. So this becomes serial in, serial out. Okay. This becomes, oh sorry, serial in, parallel out. So this becomes serial in, parallel out. Now what about parallel in data then? Parallel in data, from where it will come? For parallel in data, you are supposed to give all the data to all the flip-flop directly, right? Parallel in, parallel out. Now you can also think that if I have my parallel in and parallel out like this, what is the use? I can directly connect, no? I can directly connect the data of D and Q. Why all this flip-flop is required? So I will give you the answer. The flip-flop is required because I want the control over the data flow. If you directly connect Q and D without any control, the data will be permanently available from Q to D. But I want that with my control clock signal. When I press the clock, and when I make the control input clock available, then only output will be equal to input, or parallel data out QA will be equal to this DA, DB, DC, DD only when I give the control signal clock, because you know that at control signal clock only Q will be equal to D. If you do not give clock, Q will remain whatever it was, like a memory, but it will not work. So if clock is high, then only Q is equal to D. So your serial in, serial out and serial in, parallel out was very simple. Let us go to this circuit, okay, which will, now you can see this circuit. Now you have to pay little attention properly to this. All of you see very, very carefully. What you can see, you have your 4D flip-flop as it is, the way it was there in the previous simple shift register circuit. 4D flip-flops are there, and QA, QB, QC, QD are also there, right? So this is your parallel in unidirectional shift register. So what is happening in this is, that you have your data loaded here. See, parallel data in has to be loaded in a specific manner. Okay. So what do? Is we have a control signal called as load bar or shift. Load bar or shift. Now you see what will happen if I make load equal to 0. See here, if I make load equal to 0, it is an active low signal. So load equal to 0 means I am activating load. Activating load means data is being loaded. Data being loaded means what? If I make a 0 here, this NOT gate is there. This NOT gate will make a 1 here, right? Now you see what is happening. This 1 is going into this second AND gate of all the 4 flip-flops. This is second AND gate of all the 4 flip-flop. So this one, when it goes to one of the input of all the AND gate, what will happen? This is my parallel data in. This is my parallel data in. So when 1 is one of the input of all the 4 AND gate, this IA, IB, IC, ID are the parallel in data available, and all this, as soon as load is equal to 0, you get a 1 here. You will get your input data here. IA will come here, right? Same way, IB will come here, IC will come here, ID will come here. So all your parallel data gets loaded. all your parallel data gets loaded, and it gets loaded. Where it gets loaded? It gets loaded to your D flip flop. So because this is an OR gate, without bothering about your shift or second AND gate, if IA is here, your input data is here, parallel input data is here, then what will happen? All the 4 bit of the data, which is named as IA, IB, IC and ID here, will be loaded here. And OR gate, this will also be equal to IA. It will not depend upon your input. Why it will be equal to IA? Because load is 0 na, load is 0, load is 0, load bar is 0. So here you are having a 0 only, here you are having a 0. So that means here also you are having a 0. You are having a 0 means here also you are having a 0. So if it is 0, then IA is directly put as input of this D flip flop. So when load is equal to 0, your parallel data in gets loaded as the input of the 4D flip flop. So all this at first clock cycle, this combinational circuit will work, and your IA, IB, IC, ID becomes the input of your 4D flip flops. And when in the second clock cycle, QA will become to IA, QB will become to IB, QC equal to IC, and QD equal to ID. So all the 4 output will become equal to input in parallel data out. So this is the case of parallel in, parallel out. Now let me show you the previous case. Let me show you the previous case. Previous case shows what? Previous case shows that it will be in the shift mode. It will be in the shift mode. So what will happen? Now what will happen? It will be in shift mode. Shift mode means what? Shift mode means your load bar will not be 0. It will be a 1. It will be a 1. So if it is a 1 here, if it is a 1 here, so here it will be a 0. If it is 1, here it is 0. Now your second AND gate is not in working mode. Parallel in means it was in working mode. Now this second AND gate is not in working mode. So when this 1 goes in, your serial data will go in, and this serial data will pass from here to here, and it will behave as your normal shift in, data in, data out serially if you are taking it after 7 clock cycle, parallelly if you are taking it after 4 clock cycle. So your serial in, serial out, and serial in, parallel out behaves the same way. Behaves the same way means the way it was behaving in your previous circuit. So then this becomes your SISO and SIPO, PIPO. I have shown you. Now what about parallel in, serial out? Parallel in, serial out, what will happen? For only 1 clock cycle, your loading will happen. Load bar. So only for first clock cycle. For first clock cycle, your load will be made equal to 0. For first clock cycle, load will be made equal to 0. So what will happen? In my first clock cycle, all this IA to ID will be loaded here, and it will be available to all the 4D flip flop. After the first clock cycle, second, third and fourth clock cycle, this will be in first clock cycle, it will be in 0. Second clock cycle, it will go to shift. So for loading only this is used, and then shift. So what will happen? Your data will be available one after the other at serial data out. Loading happened in first clock cycle, second clock cycle onward it will be shifting. So that becomes parallel in, serial out. Okay, so this is about your 4 types of this. So what I have taught you now is serial in, serial out, serial in, parallel out. So these 2 things I have taught with respect to, these 2 things I have taught. These 2 things we have seen only with the D flip flop, right? And these 2 along with up we have seen with this circuit, unidirectional shift register. So parallel in serial out, parallel in parallel out, and also it was taking care of these two. So these things I have taught you. In the next class, we will see universal shift register, which is little complicated than all these things. Okay.